Yeah. Because we have installed the game, we can now import it, right? So this statement, this line would fail, would return an error if the game had not been installed with pip. All right. Now the game package has a lot of other packages inside. So once we have imported the pygame package, the pygame.locals package becomes available, so we can import star out of it. The pygame constants becomes available, and I'm going to import everything as well. All right. Not sure whether I really need sys. I'm just going to leave it there for a while. All right. So I'm going to keep with the tradition. I'm going to open a window special for the game, right? This window is going to be was going to need some width and height, and because we want to sort of make it, not make it 800 by 600 should be enough, right? And I am going to get all these elements again created automatically. So leave it here. I'm going to let you write all this stuff while I explain. These are just variables. We can give it, they're ours. They're our choice, right? Now, with these packages, we create an object that is a rectangle, right? And this actually represents the window that is going to open, all right? And that, this entire package needs an initialization. So we're going to write this. All these are boilerplate. No matter what, whenever you're using pygame, you're going to have to do them verbatim. All right? We're going to want a certain repetition ratio for whenever we keep a key pressed. So if you keep a key pressed, normally, right? What happens is that there's no repetition by default. I have no idea about this. What happens if I keep, okay, so you see, if I keep pressed on N, there's a little delay after which the key starts repeating, and then there's a certain frequency of repetition. Typically what you want in a game is that this frequency to be very high, right? So we're changing it. We're setting the repetition to whatever these arguments represent, and I'm going to find out what they represent for you. I'm going to say pygame manual. And at some point we need to have set repeat, key set repeat. Which is here, change the keyboard repeat. And we have a delay and we have an interval, right? So these are exactly the what I was talking about, right? So there's a delay until the first repetition occurs, and then there's a frequency with which the subsequent repetitions occur. These are timings in maybe milliseconds. Probably milliseconds. Typically all times are milliseconds. Is the amount of milliseconds, yeah. So I'm setting that the repeat should be, the first repeat should be after 1 millisecond, and subsequent repeats should be after 10 milliseconds. We want to have 32-bit color depth, which nowadays is standard. All right. Depending, for instance, you might work with a Raspberry Pi, which might not have 32-bit depth for colors, might have fewer colors. You might work on different other kinds of devices that run Python, and it may be less, right? So normally what we should do is query what is the best, what are the modes that are available, and then based on that to try to select the best. But since I know that everybody has a computer with a pretty decent graphics card in front of them, I'm just going to default to 32, right? So we're going to say that, yes, we want a screen rectangle of the size with width and height that were defined here, right? And this is display mode, right? We want it to go to best depth, which is 32-bit, all right? And there's a title for the window. You see this editor, this IDE has the title pygame.py-untitled workspace, right? So this string that goes in here can be set by this command. And our game is going to be called Asteroids, but maybe tonight we're going to say pygame tutorial. And we want a clock. The clock is very important has a bunch of utilities inside. It's an object, has a bunch of utilities inside related to measurement of time that are going to be very important later. I'm not going to go into the game, all right? But I want to explain the structure of the typical game. The structure of the typical game is a loop while true, all right? So I'm going to do the same thing here. And then inside, we're going to read an event. And the first thing we want to be able to do is quit, right? Because we're going to test the code, we're going to test the game, and we're going to see that it's not working the way we want, and we want to be able to quit as fast as possible, right? So the one thing that I want to be sure from the very beginning that we can do is quit. And this is why I imported sys here. So I'm going to take this. I don't need all of it, all right? And oops, I don't need to go here. I'm going to copy it over here. All right, so this line is too much. So whenever we type from the keyboard and whenever we press the mouse, right? You should think of these events. They're events, right? The event of typing on a keyboard, the event of clicking on a mouse key. Maybe you have a touch screen, the event of touching the screen. They're events. And then these events are encoded as a piece of data. And those pieces of data, they go one after another in a sequence, which is like a list in Python, right? And then we want to check these events one at a time, right? So this invocation, pygame.event.get, will give me one event at a time, right? So everything that happens from the computer, maybe not just keyboard events, maybe I plug in a USB, maybe I pull out the USB plug, maybe a network packet arrives, right? All these events are stored in this sequence, and the sequence is here, right? So I can get one event at a time by creating a loop. So notice that there's a nested loop here, all right? So there's a loop that will be infinite, will run forever, all right? Inside here, I read the event that is coming next from the keyboard, yeah? And if the event happens to be quit, let's close this, right? So quit is typically Control Q, or it's typically pressing the red little dot here, right? Or we also want to use the key escape to be able to quit, right? So either the event type is pressing the little red button here, the little red button there, or it is pressing the key escape. If this happens, we want to quit, all right? When we quit, we have to quit the package first, which does some stuff. You see, everything here performs some settings for the graphics card. We have to undo those settings. So this is what happens here. And then this is what exits Python. You know that already because you can type exit from the keyboard, right? You can go in Python, and if I type exit, we exit, right? So alternatively, what exit really is sys, and I can say sys.exit, same thing. Yeah. So essentially, we leave the program if that happens. Now, we're going to put some more stuff here. Yeah, but later. So let's see what happens if we run this. All right, I just want to make sure that everything is set up, at least on my machine, so that everything will run. So we save this, and I'm going to do Python 3. I haven't changed folder. cd week 5 Friday and Python 3 pygame, and it didn't work. Yes, I know exactly what's happening. Unfortunately, I chose the wrong name. I called this program pygame. So the name pygame here and the name of the package that we have installed are the same, right? So therefore, I'm going to change the name of this. I'm going to call it pygame tutorial. All right. So I'm going to close this. I am going to open pygame tutorial. All right, this is saved already, and let's run pygame tutorial. All right, so notice that it opens a window. The window is currently empty. The pygame name appears here. And remember, we are in an infinite loop. So what happens is that this while true never ends, right? But while we are inside while true, we check for all the events inside the event loop. So now if I'm going to press escape, all right, I exit. The same will happen if I press here. You may think that this is automatic. This should be automatic. If you remove the for loop, and actually let's show you, right? So you saw I pressed on the red button and we exited. If I remove this, I will just comment it out. Let's run again, and you're going to have the strange situation. Okay, so there has to be at least one statement. So I'm going to say skip. Remember, skip is the statement that does nothing, but this is one very good purpose for it, right? I want an empty loop. I just want something that never finishes, just for the purposes of experiment, and I can use it. Sorry. Pass, not skip. Pass. Yes. And now, with this code where the event loop is commented out, you can't click on the red button, right? This will never end. So the way to actually finish this is to go into the original window and press Ctrl+C. All right. Now, if you do this from inside the IDE, which some of you might be tempted to do it, right? You're going to have a problem with that because there might not be an opportunity to press Ctrl+C, which is why I asked you from the very beginning to run everything from the command line. Okay, let's undo all this. And going back to the documentation, let's print a little text. Let's start with that. So display, pygame display. All right. Oh, it actually can play movies. I never got that far. And let's find a very simple example. All right. So we're going to take a text. This is another one. This is not what I want. All right. So let's take a so we have to start with a font. All right. So again, boilerplate. The font part of Python has to be initialized, right? So we have to do this. Then we obtain a font from the system. So we're going to use Comic Sans MS. Why not? With a size of 30. All right. And then this font is an object capable of rendering. So we create a rendering of the text, right? So we're gonna try to say something more interesting. Pygame is fun. And this will be the color. All right, and we want black actually. So this color would be black. The color has three components. I think we discussed this before. Can't remember we discussed this before. It has three components: red, green, and blue. RGB. Obviously, what we use is a full number of bits. We use 8 bits for each of them, which means that each of the intensities of the colors are values between 0 and 255, right? And with the combinations of colors, we create different other colors, right? If all of them are 0, I'm going to get black because that's the least intense color. If all of them are 255, I'm going to get white because that's the brightest color, right? If the first value is 255, I'm going to get red. And all the others are 0. If I have 0, 255, 0, I'm going to get green. If I have 0, 0, 255, I'm going to get blue, right? If I have the first two 255, so between red and green, I think it's, let's experiment. I'm not good with colors. This text surface is copied literally on the screen at these coordinates. So I'm going to put coordinates that are a little bit more central. So I'm going to say 100 and 100. So let's do this for the beginning. I can't remember what the false is for. Let's actually find out what the false is for. Well, we'll find out. Maybe I'll just change it to true and I'll find out. So let's run again. No? Oh, I have to do an update. So I have to do at least one update. Which update? Is it this? Sorry, why don't I look here? That's the easiest way. Okay, this one. We go here, and I can do this. All right, now you see this loop loops around very, very quickly and consumes a lot of cycles. Now, in order to display on the screen, and to have the feeling of movement, we need to only display about up to 100 frames a second, right? So 100 frames a second is a very, very good display with a very, very good game. Actually, most games will try to push the CPU so high that they can only display about 30 frames per second. At 30 frames per second, the quality of the illusion of movement is still good, right? How do we perceive movement from the screen? We see many, many images, right? About 30 of them per second. And because they're displayed so fast, the eye is tricked into believing that they're moving, right? But it's many stationary images, right? Now, it turns out that the processor is so fast, it can go many more times around than 100 times a second, which would be the need for doing 100 frames a second, right? So because of that, we actually want to slow it down. And we slow it down by using the clock. So we're going to say, well, we don't want this to be more than 60 frames a second. If it's less, that's fine. But this command here will just tell the graphics card that if the previous update of the screen was less than 1/60th second ago, then pause and wait until 1/60th of a second has elapsed and only then do another update. Now, for a CPU, 1/60th of a second is a very long time, right? It's centuries. Yeah? So, and we don't want to overload the CPU. A value of 30 here is actually quite sufficient, at least for today. So, I'm going to try to do this again. Oh, and unfortunately it has turned black. Why black? All right, because it has turned black, we are using black on black. So let's use 1 to 8. 1 to 8. Let's use a color that will display on either black or white. And I want to see this text. Yes, we now see it. Pygame is fun, appears here. It's very likely that the font was not found. This is not Comic Sans MS. So the font was not found. We're going to try to find maybe a different font. It's being displayed here. I'm wondering if this is really a size of 30. So let's experiment a little bit with the font. So let's say I want a size of 100. Okay, let's make it more central, 200 and 200. So these are the coordinates. It takes a while to warm up. And okay, so now we have it a little bit better. So 200 and 200. 200 and 200 should probably be the top point. You can imagine this text as being inside a box. Imagine a box going around the text, right? The top left corner of the box is at the coordinates 200 and 200. Okay, let's experiment a little bit with colors. So let's say I make this one 255 and then 0 and then 0. So everything should turn red. Yeah, so now we have red color. If we move the 255 in the middle, I get green. Yes. And then if we move it here, at the end, we're going to get blue. All right. You can create combinations. So let's say green and blue should be yellow. No, green and blue is this color. What do you call it? Turquoise? Cyan. All right. How do I get yellow? Red and green is yellow. And then, well, the fun thing to do is always put, okay, there we go. I should learn these things. I'm more of a programming languages kind of guy. Use random numbers here, right? Nevertheless, I like the color yellow very much, especially on a computer screen. Cool. So how do you find out how to create color? And then, right, you can take this somewhere where you find colors that you like. I would like to do, yeah, an orange, say, and then I can go higher intensity. Right, everything goes from the highest intensity to black, which is the lowest intensity. So let's say I want an intensity like this, and I would see these values, right? But you can see them in decimal here, 232, 124, 16, right? So if I go now and let me just copy them because they're in the right format and put them here. As I run this piece of code, I will get that color. Cool. Let's animate this text on the screen. One thing I asked, I was thinking, is to play with the font. So let's, those of you who have Windows, did you get with Comic Sans, did you get the actual Comic Sans? Yeah, right? Right, so macOS is not a Microsoft machine, therefore Comic Sans is not available. So I'm going to try to use here Verdana. Which should be a universal font. No. I don't think I have that issue. All right, so one thing we can do is actually print this. Let's do this. And we're going to find out what fonts are available. So before doing this, I'm going to say print. Oh, whoa, there's a lot of them. All right. So there's one called Verdana Ball TTF. So let's try this one. Okay, so this worked now. We can make it a bit smaller. So let's reduce it to a size of 50. So by the way, do the same experiment, right? And then pick something that works for you. I'm not sure. Verdana should be reasonably universal. Another one should be Arial TTF. Let's see if I can do Arial TTF. I'm gonna downgrade this to 60. Okay, Arial. All right, let's animate this text on the screen. So I'm going to not do this anymore. All right, so instead of doing the blit, you see the coordinates are here, right? So instead of doing the blit outside of the loop, I'm going to do this blit inside of the loop. All right, so in between here, let's mark these. So in between these two marks is going to be what we consider to be the useful code. Everything else is boilerplate. Yeah, more or less. So whenever we want to start a piece of code, the code that we really want, that is really useful to us, is in between these marks. The rest is going to be pretty much boilerplate. We have to put it every time. Okay, and you're going to ask me, isn't that stupid? Kind of is, right? But Python is only this much evolved, right? If you want something that is exclusively specialized for games, then you can build your own programming language. All right, so this blit is going to come here.
Do they use, what is it called? Apple has it, it's called, they use it for developing games against Swift, yeah? Yeah, they use Swift, don't they?
They can, yes. No, but Swift is a generic programming language that has pretty much the same amount of boilerplate that Python has. I mean, you can go ahead and learn Swift. You're still going to have to go through these kind of initializations, all right, that don't much make much, unless you're a real, you really have an understanding of what a graphic cards is. You don't quite understand why they're needed, and you just have to write them there every time, right? All right, another thing that we have to do is actually wipe the screen. All right, so I'm going to wipe the screen, and we can wipe it with any color we want. So it's already black, and I'm going to keep it to be black. Why? Every time we print, next time when we come around, if we haven't wiped the screen, the text will still be there. So we're going to print many, many copies. And that will not lead to the illusion of animation. What we want is to wipe and draw again, wipe and draw again. All right, so what kind of animation would you like? Let's start with something simple. Let's say we want to move it on a diagonal, right? So it moves from, say, 50-50 to maybe 500 to 500. It reaches to the bottom and then comes back up, right? And it sort of oscillates back and up, right? So we're going to have two coordinates, x and y, right? So I'm going to say x equals y equals 0, and now we learn another interesting thing. No, actually I can't do that. I can do, let's just put them separately. 0, y equals 0. I can put it as a pair. And actually we should start at 50. All right. And then we're going to have a direction. So 1 is going to be downwards, which means increasing coordinates. And then -1 is going to be upwards, which means decreasing coordinates. Coordinates are a bit funny, right? In mathematics, y is upwards, x is from left to right, and y is upwards, right? Here, y is downwards, right? So meaning that the point of coordinate 0, 0 is in the top left, all right? Anything, the origin of everything is top left, right? So if I have a box that is the text, the text that identifies the position of the text, the point that identifies position is the top left corner of the box. So we're going to start with the direction of 1, and then we're going to say that, see, we are inside this big loop, so we have to think of the next step. We are at x, y, and if the direction is 1, we just go to the direction of x plus 1 and y plus 1, right? So we're going to say that screen split of x and y, yeah, and then x is x plus direction, y equals y plus direction, right? And then if x is greater than 500, we're going to have direction equals direction -1, right? If x is smaller than 50, we're going to have, actually it's the same thing. It's actually not direction equals direction -1. Direction equals minus direction. If x is greater than 500, or if x is less than 50, all right, we're going to change direction. And by changing direction, we go from direction to minus direction. Okay? So this thing either increases the x or decreases the x. As soon as we are just a little bit outside of the legal values, we change direction. Okay, let's see how this works. Right, so let me explain this again. So we're assuming this is the current state. X and Y represents the current state of the text. And I have to think only, because I'm already inside the loop, I have to think only what is my next state. So, right, I know the state, I render the state, this is the rendition of the state, right? And I have another piece of code that takes me to the next state. The next state is one where X is either increased by 1, X and Y are either increased by 1 or decreased by 1. Okay. So let's see what happens. So you can see now the animation. So it keeps going down. At some point it's going to be reflected, comes back up. Okay. Now, what should I do if I want this to go faster?
Change the clock.
Yeah, let's try to do that. So we could try to change the clock to 60. Depending on how fast the computer is. See, it's a little bit faster. You would get more frames per second, and then it becomes faster, right? However, you will hit the limit, the hardware limit, very quickly. I don't think this one will be able to do 100 frames per second. I very much doubt that. It's an Intel graphics card on it. What if I increase the direction? What if I say 5 here? Will this make it faster? Yes, it will, because every time I'm going to skip by 5 pixels. Would the animation be too grainy? Yeah, well, that's another concern. So you can be concerned about the fact that the animation might be grainy, right? So at some point, if the difference between two consecutive images is too high, then you will see the graininess, right? So for instance, if I increase this to 100, well, actually 100 would be too much. Let's say 50. Right? So you notice that there's times when you see more than one image. Actually, this is over the network, so you don't see exactly the same thing that I'm seeing, but hopefully you're seeing it on your own machines, right? So the image is a lot grainier at this point. Cool, right? So by making animation go faster, by increasing the difference between two consecutive images, you can make it appear that the animation is faster. All right, what if I wanted this text to move in a circle? So instead of moving in on a line, I wanted it to move in a circle. So let's say that the center of the circle is right in the center of the, I'm going to call it CX and CY, right in the center of the window, which is, so I said 800, 600, right? So 400 and 300. Yeah. And then I wanted to move on a circle of a radius of, let's say, 100. So I'm going to have a radius. So you see, inside this loop, there's something that has to change all the time, right? Now, if we are going to put this thing on a circle, right? So imagine the text going like this, right? And going at a constant rotation rate. What should be the thing that changes? What should be the thing that controls the position?
The middle stays the same, and the X and the Y.
Yes, the middle stays the same, the center stays the same. And what should be the thing that controls the movement?
Direction.
Think of a clock.
It's kind of like a pivot.
The middle of the
Louder?
middle of the window.
Well, the middle of the window is fixed. If you look at the tongue of a clock, right? You have an analog clock, which you have seen analog clocks, right? Nowadays, you can never be sure. Right? So you look at the tongue of an analog clock and it rotates, right? What changes?
The angle, right?
The
Angle.
angle. Very good, right? So it will be good to have this controlled by an angle. So instead of a direction, I'm going to have an angle, which starts at 0. All right, and this angle, somewhere inside here, is going to increase by a certain amount, which is how fast the animation is. And this angle should be measured maybe in radians. And, right, radians, so if I take radians and turn them into a circle, what do I need to use? Ten is too much. 0.1. How do I get from an angle to the position?
You don't multiply the radians by the radius.
Louder?
The radians by the radius, you just got to multiply to get the circumference of a circle.
Okay. Get my magic tablet again. All right, so let's get a brighter color. So this is my center, right? Which is at coordinates, we were saying 300 or 400 and 300. 300, right? And then I have a radius r, and I have my angle alpha. Yes, these coordinates x and y, so this is x, c, y, c, right? These coordinates x and y are what? X equals to no? xc plus r cos alpha. Y equals yc plus r cos alpha. Is sine alpha, sorry. Yes? Too much? So let's compute the x and y. And now we should import math. So from math, import sine, cosine, all right, so sine, cosine, angle, y equals yc plus radius times sine angle. And remember that these functions are periodic. So I can let the angle to keep growing. I don't have to reset the angle, right? Angle comes to 2 pi, and I can actually let it continue to grow and grow and grow. My sine and cosine are confined to the interval 0 to 1. Yeah. So this is it. This is my current rendering. This is my next state. So let's see how fast it's going to be now. Oh, xc is not defined. Oh, cx. Cx, center x, center y. Okay, so you can see it going on a circle. All right.
This is valid rect style object.
Again?
This is valid rect style object.
Take a close look at the code and see if you copied everything properly. Everybody else? Anybody else has the same problem? No? You're not seeing anything? Okay, run. You haven't saved, first of all. Right, run. I'm not sure. I mean, you're copying and pasting, and sometimes indentation can. So there's two problems. You see, you're getting screen filled, and there's no extra level of brackets here. Right? There's an extra level. Oh, you missed this one. Cool. So let's do some corrections. So it seems that it's a bit too low and too far to the right. So I'm gonna reduce this to 300, and on the y-axis I'm gonna reduce it to 200. Maybe not 200, 150 should be better. Okay, this is a bit better. Now, what happens if I increase this value here? So I'm going to actually call this angle delta. And if I put this to 0.2, is it going to move faster or slower? Faster, right? So there you go. A bit too grainy. But actually what I want to do is let it move very slow. So I'm going to say 0.02. Let's see how this one works. Okay. Now, you must have seen this as a screensaver at some point, or maybe not. Maybe you're that's too far in the past. There was a time when screensavers could only do this, a bouncy ball on the screen, right? So let's do a bouncy ball on the screen. We have just the amount of time that we need. And we, in this way, we're going to learn how to draw a circle. All right. Let's see, how do we draw a circle? I'm going to go very quickly and say pygame, draw a circle. Pygame, draw a circle, screen, color, position, and I think radius. And I don't know whether this will be filled or not. Let's give it a try. So I'm going to start first by just drawing one single circle. I'm going to put it in the rendering part, right? So this is our rendering part. So I'm going to say so we have a screen. Yes, and we want a color. Let's make it red. We want a position, so initially we're going to say 100 and 100. And we're going to take a radius of 50. And let's see what happens. Yeah, so we have a filled circle, filled red circle. The next thing that we want to do is to have it bouncing. We're going to do a very simple thing. We're going to have it at going on diagonal directions, right? So either 45 degrees downwards, 45 degrees upwards, right? Either to the left or to the right. Right, so as far as the ball is concerned, right, I'm going to call it a ball, bx. Initially, we're going to start from the position 100, by equals 100. So these are the coordinates of the ball, right? And then we are going to have two directions, right? We're going to have a dx, which is going to be initially 1, and dy to be also initially 1, right? And whenever we touch the border of the window, we're going to reflect. We're going to change direction. All right. So we're going to draw the circle on the screen on color red at positions bx, by, and we're going to leave the radius to 50. br equals 50. This is the ball radius. All right. All right. And then we have to compute the next state. So what's going to happen here? Well, if dx is greater than if dx is greater than and what should I put here, right? Well, I have a width and height, right? When do I reflect the dx, sorry, bx? When bx is greater than, so the edge of the ball has to touch the window, right? This means that the center is at the width minus the radius, right? So when bx is greater than width minus radius, br, or when do I have to change direction? When, right, the ball goes outside to the left, right? When the edge of the ball has a zero coordinate or a negative coordinate, right? But that means that the center goes below radius, right? So bx is less than br. So in that case, I will change the direction on x. So I'm going to say that dx equals minus dx. Similarly on y, if by is greater than height minus br, or by is less than br, then dy equals minus dy. And we go around. Yeah. Now, probably the speed is too small, x and 1y, right? So I'm going to make it something like 3. Speed it up a little bit. Oh, I forgot to update the state. So angle goes to angle plus data, right? And then bx should go to bx plus dx, and then by should go to by plus dy. All right, so we have a bouncy ball with a text that rotates in a circle. All right, so this is all the philosophy about creating animations. So now you have your own screensaver. Okay? Everybody has managed to obtain this? Or something like this. Now one thing we can play with is have different velocities on x and y. So let me make the x 5. Right, so now you're going at slightly different angles, right? It's still bouncy, but it's not 45 angles anymore. I don't know what angle would be there. Okay, and another thing you can do is make it bounce at random angles. All right, so let's try to do that. So I'm going to get a package called random. I'm going to go and steal it from last time. So from random import random. I'm actually just going to say import random. All right, and then Let me remember how it works. Python 3. So you see, if you call it successively, every time you get a random number between 0 and 1. All right? So we want a random number between, say, 1 and 5. Right? So I'm going to say here times 5 times random dot random. And let's see what happens. Right? So this will create, and times dx was 5 and dy was 3 times 3 times random dot random. All right, so now the angle of reflection is going to be random. That will make it a little bit more fun. Oops. Oops. I see, it's integer and it's expected to have float. So let's create an int out of this. Why so high though? Oh, no, it's actually, it was high and it was stuck at 0. So let's let it never be 0. Let's put a +1 here. Inside. Oh, to get that far. Really? Okay, how do I fix this quickly? All right, so then I'm going to say just put a 2 here. Greater than 10. So I'm trying to limit the growth. To make it a little bit more fun. Okay, so this is a bit more fun in the sense that it's a bit more random. Okay, something like this. So, next step was going to be to try to create an asteroid game. Okay? Which you will have on Monday with recordings. And next week, we will talk about data analysis. So we're going to look at some government data. The Singapore government, as any government actually does, publishes some data in computer readable format that we can just download and process in Python and do some analysis. Yeah. Questions? So this is the code. Okay, I'm going to, even though it's not recommended, just to make it more compact, I'm going to write it like this. All right, so you can see the two parts, right? So this part we're going to call rendering. This part we're going to call next state. All right, so what we do is essentially perform the actions of placing stuff on the screen and then figure out what should be the next state. The next state is always controlled by certain abstract values, right? So for instance, position of this text is controlled by an angle. Why? Because why is it an angle? Because with an angle and having the angle increasing at a uniform speed, we can control a uniform rotation of the text, right? For the ball, it's the position XY, right? And then what happens for the next state? For the text, it's very simple. We just compute a new angle. For the ball, it's a little bit different, right? It's more complicated. We have to check whether the ball is about to be reflected. And then if it is, we have to change direction. But by and large, most of the time, these are all false. Most of the time, all we do is this. We're taking the current position, we're adding the direction, right? In the world of the computer, most of the frames are in the middle of the window. The ball is in the middle of the window and not being reflected. Reflection is kind of an exception. I know it happens about once a second when we see it under our eyes, but for the computer, it happens once every like 60 frames, right? So 60 times, one out of the 60 times, one of these is true. But the 59 times out of 60, only this gets executed. All these if statements, they are false. All right? Cool. Questions? If not, see you next time.